Okay, we look at reviews, okay? Let's go back to what? Reviews, okay? So this is what we'll be doing until we write our exam. After normal class, we'll have a review. Even if it's few minutes before our time elapses, we have roughly 30 minutes, 21 minutes. So let's look at this. The question says methyl salicylate has a density of 18 gram per ml. It's 1.8 gram per ml. Calculate the weight of 450 ml of methyl salicylate. Okay. What's that? Calculate the weight of 45 ml of methyl salicylate and calculate the volume occupied by 60 gram of methyl salicylate. Who can solve this question for us? Who get mine? Angela, come. Have you tried it? Have you tried it? All right, this question is from density, specific gravity, and the specific volume. That's where this question came from. So, from your physics, remember, the density is what? See. This is what? Mass over what? Volume. So it's the same thing here. Density is what? Mass over what? Volume. Now, specific gravity. Specific gravity is ratio of what? Weight of what? Substance. Weight of equal volume of what? Water. Specific gravity, specific what? Did I get it? Yes. Is equal to what? Weight of what? Of a substance over what? Hey. Ife a ga-anara ka Chinese to ndị arị agụ akwụkwọ. Nyochaa onwe gị malụ ma iso. Ọ bụrụ na iso gụba akwụkwọ gị, ọ yọrọ maara. This will be strange to those that don't do what? Study. Is there in your course material. So, specific gravity is what? Weight of a substance or weight of equal volume of what? Water. Now, you know, there are some people here, those things we are doing here, You look as if we are dragging them backwards. I understand. Please bear with us, okay? I understand. Please bear with us. We need to help the weaker brethren. Now, so now this is your own time now. Now, weaker brethren, please be strong. Bear with us now, weaker brethren. Basic gravity is weight of substance over what? Weight of equal volume of water. The issue now is, what is the meaning of weight of equal volume of what? Water. That's where the issue lies, and that's why some people may find it difficult to solve this question, because they don't understand the meaning of weight of equal volume of water. That's what I want to explain now. So listen. Now let's assume now you have your is there any used people don't drink again. Another one. That one is what? Water. As for all million now, water. What's the quarter two here? Yeah. Let it be up to two. Poster. She has said it. The second, my agony. Up here. It's small, right? So I get like getting there now. So she will give us drinks every day. Now listen. Listen, listen. Let's assume now, you fill this with water. Okay, they don't have the same volume. I need something that this one haven't seen. Is there any other 50 cl or 75 cl? That's what okay. Just after I take it, don't worry. Pour her in. Bring it here. Angela, bring it here. Alright, keep it here. Now, these two, hello, are we together? Yes, sir. Two of them, they have the same volume. This is 75 mil. Sorry, cl. This is what? 75 cl. Even though the size, they don't look at the sizes, but they have the same capacity. 75 cl, 75 cl. Now, if you fill this with water and keep 75 cl and fill it with sand and keep, two they have the same volume, right? Two they have the same volume. Good. But if you weigh them, this one will be the one that has sand will have more weight than the one that has what? Water. So if you want to really take whether compare like that, these two people now, these two friends now, if you compare two of them now, you cannot say that this one is this her weight may be more than her weight too, but you cannot say that she's heavier than her, because you have not compared the volume. Yes, you must compare the volume first the volume must be the same thing. If the volume if the volume is equal, and this and one of the weight is more than the other one, that way you can say that this one is heavier than this one. Am I communicating? Am I communicating? Now, weight of equal volume of water. Specific gravity of a substance is the weight of that substance over weight of equal volume of water. Now, weight of that substance, if you want to calculate the specific gravity of a substance, you divide the weight of that substance over weight of that substance that have the same volume with what? Water. That's the meaning of this weight of equal volume of water. Weight of that substance that has the same volume with what? Water. That is when you are actually comparing their what? Weights. Am I communicating? How do I explain this again? French, right? Okay, look at these two things now. Two of them. This one has sand now. This one has water. Now, you weigh this sand and keep. And weigh this water inside there and keep. If you divide the weight of this, the sand now, and weight of this one, the answer you get will give you the specific gravity of what? This sand. Am I communicating? Because that, remember I told you that you have to, their volume must be what? Equal before you can do a comparison, because we are just trying to compare. It's a ratio of weights, weight of substance, weight of water that has the same volume with that what? Substance. So now, if you come here now, but in specific gravity, the standard is water. What you use to standard is water. If you are dealing with what? Liquid and what? Solids. But if you are dealing with what? Gases, the standard is what? Is what? Hydrogen. If the substance in question is a gas, you calculate its specific gravity using hydrogen as what? A standard. But if the substance is a solid or a liquid, you calculate the specific gravity using what? Water. So you can have this definition as the specific gravity of a solid is the ratio of the weight of that solid to what? Weight of equal volume of what? Water. The gravity of a liquid is the ratio of the weight of the liquid over the what? Weight of equal volume of what? Water. But if you want to now check the specific gravity of oxygen now, it becomes, or a gas, generally, because the weight of the gas over the weight of equal volume of what? Hydrogen. Because for gas and for gas you use what? Hydrogen as a standard. For solid and liquid you use what? Water as what? Standard. Do you understand this weight of equal volume of water? This water here, this sand here is there. They have the same volume. You now fill this with water. This is the sand. This is the weight of the sand. This water here have the same volume with this sand. Hope you know. Are you aware? This water here have the same volume with the sand, but you don't have the same weight. So weight of equal volume of water here now is now weight of this water. Weight of this water inside here that has the same volume with this what? Sand. Am I comparing? Because you are comparing the two of them. Now, if you compare the two of them and this sand, and you get a value that is less than 1. If you divide them and you have a value that is less than 1, what it means is that water is heavier than this what? Sand. Am I communicating?
Yes, sir.
But if you divide them and you get the specific gravity that is greater than what? 1, it means that this substance is what? Heavier than what? Water. It's not when you have a higher, a greater numerator, let's say 3, divided by a lesser denominator, let's say 2. You have 1 point what? 1 point what? 5. 2 of us. But if you have 2 over what? 3, you have what? 0 point what? 0 point whatever, 6 whatever. Are you there? Now look at this implication. The one on the top is the weight of the substance you want to check its specific gravity, while the one below is the weight of water that has the same volume with what? This substance. So if weight of the substance is, if you divide it and you have a specific gravity that is above 1, this is above 1, it means that this substance is heavier than what? Water. But if you divide them and you have a specific gravity that is less than 1, it means that this substance is what? Lighter or less dense, okay? Or that water is heavier than that what? Substance. If you get oil and water now, let's compare liquid now. If you get oil and water, do you know why if you get sand, if you get sand now and pour sand here and pour water, where will water be? True of us, even though it may absorb, but initially to be here. True of us, do you know why? This sand is heavier than water. Am I completing? Now, if you mix oil and water now, oil will float. Specific gravity of that oil will be less than 1, because the oil is less than is lighter than what? Water. Now, if you calculate the specific gravity of that oil, you find out. That means you write the weight of the oil on top, right? Then compare the same volume of water. The weight of water that has the same volume with that oil will be here. If you divide it, because water is heavier than oil, this one will be higher than the weight of water. Only the same volume with this oil will be higher than the weight of the oil itself. And if you divide it less than what? 1. Does it make sense? With these two things now, I've said now, I think this little explanation is what we need to solve this question. The question says, methyl salicylate has a density of 1.8 gram per ml. Calculate the weight of 45 ml of methyl salicylate and calculate the volume of comparison and say, okay, we may not need it to. But it's better you have it. You know it in case. You may not need it, but it's better I explain this. At least I will not explain today. What was? 1.18. Okay. 1.18. Okay, good. Okay, let's analyze the question again. It says methyl salicylate has a density of what? This is density of what? Methyl salicylate. Calculate the weight of 45 ml of methyl salicylate. Density is what? Let me use it as a symbol. Density is what? Density is what? Good. Now we are giving the density of methyl salicylate to be what?
1.18
gram per what? Ml. And the weight is what?
45.
Here we can use both weight and mass interchangeably. Okay? The weight, let me put weight here. Weight is what? 45 what?
I give us no.
No weight. Good. Volume is what? 45 mil. So we are told to calculate the weight of 45 mil. So the weight here is what? Density times what? Which is what?
1.1.
Times what? 45 mil, right? Mil, we take care of this mil. 45 times 1.1 is what? 53 point what? 1 what? But we have the next one, we are told to calculate the volume occupied by 60 gram of methyl salicylate. This question doesn't need what is it called? Specific gravity. It's simple. I thought it requires us to go into specific gravity. That's why I explained it. You can also you also use this formula to calculate this. Since we already know the density, right? We want to calculate the volume of what? 60 grams. It's simple. If you make volume the subject of the formula here, right? Here volume becomes what? Volume becomes what? Huh? If you make volume the subject or the formula here, this is A, B part. If you make volume the subject of the formula, volume becomes what? Weight over what? This, right? Weight is what? 60 gram over what?
1.1.
Gram will cancel gram, mil will come up. 60 divided by 1.1 is what? Huh? 0.8 what? 5 mil, right? You can leave that 50.8 mils, okay. Or 50.9 mil. So that's the answer. It's simple. I thought it's any other question. It's simple. Oh yeah, come and write on the board fast. But you also what I said about specific gravity, right? It's simple. Biko. All right, let's look at this question. The question says, look up, please. The question says, Oragaban optic drops. Oragan, sorry, listen carefully. Oragan, not Oragaban, sorry. Oragan optic drops contain, what is optic? Eye. Ear. Oragan, can you put this on Oragaban? Hey. Oragan optic drops contains antipyrine 5.4%, benzocaine 1.4%, acetic acid 0.01%, eupoligin cosanol 410. What will be the content of antipyrine in milligram per ml? B. If a patient use 5 drops of the otic solution equivalent to 0.25 ml, how many milligrams of the benzocaine would have been administered? C. How many microliter of acetic acid would be used to prepare 10 ml of the drops? D. What would be the equivalent ratio strength, volume in volume, of the polycosanol 410? This question is not just one topic. There is concentration here. There is Masco measurement here. You must know your unit well. You must know your intra-system conversion well before you can answer this question. This one is testing your knowledge of what will be the content, is testing your knowledge of concentration. If a patient has 5 drops, this one is also testing your knowledge of inter-system conversion, at the same time testing your knowledge of ratio. Of course, how ratio and proportion is hidden inside all these questions. This one want to test your conversion from what? From mil to microliter. This one talks about concentration, ratio or concentration. So let's look at it. The first question says, what would be the content of antipyrine in milligram per ml? Look up. In concentration, we have the one we call, of course, I have explained concentration to you in your first year. So when you mention concentration, you by now it's no longer a new thing. In your physics, I remember I asked you if you have 1%, what does 1% mean? If you have 1% of solid, if it's a product that has solid dissolved in liquid, and you are told that the concentration is 1%, what does it mean? God bless you. You go far. 1 gram in what? 100 ml. That is if it is solid dissolved in what? Liquid. Am I communicating? 1% means 1 gram in what? 100 ml. That the volume must be in ml. The weight must be in gram for it to be for it to be define it like that as 1 gram. 1 gram in 100 ml. The weight must, so far it's solid in dissolved in liquid, the weight must be in gram for it to define it in that term. So if that is the case now, with that one, we can use that one to solve this number one. If 1% solution, if 1% means 1 gram in what? 100 mil. So let's look at this antipyrine, 5.4%. But you are asked what will be the contents of antipyrine in milligram per mil. So 5.4% antipyrine in these optic drops. What does it mean? Huh? Yes, what does it mean? For 5.4%, what does it mean? 5 point what? 5.4 in what? Are we together? Are we together? That's the meaning. 5.4% means 5.4 gram in 100 mil. Any question? No, we are coming. We are not done yet. Any question? Any question? So you know what this means. You know what we are told that this contains this, and the total volume of this is what? Tell me, hope you know. Are you aware? Like the total volume of this whole thing is what? 10 mil. But we are told to find what will the content be in what? A milligram per mil. A milligram per mil. I want to ask a question. Let's reason together. Do you think we should find this in 10 mil? Do you think so? Do you think it's necessary? Do you think it's necessary? From what you've discussed so far about compound, even from what you have learned, do you think it's necessary to move this to 10 mil? 5.4% of this. Generally, we know that 5.4% is 5 gram in 100 mil. That is standard, we know. But what you are preparing, is it 100 mil?
No.
It's 10 mil, right? Yeah. It's 10 mil. So the contents in this 10 mil is what? Good. What will be in 10 mil? X, right? So X is now equal to what? Times what? Over what? What's the answer? So there's 0.54 gram. If you want to prepare this thing now, if you now want to prepare it in the compounding room, you are going to weigh 0.54 gram of this for it to be in 10 mil. True of us? That's the meaning. Am I communicating now? We know that by standard, 5.4% means 5.4 in 100 mil. What will it be in this 10 mil? Because the total volume of what you're preparing is what? 10 mil. So amount that will be in this 10 mil is what? 0.54 gram. But we have even in case now we have 0.54 gram in what? We are done with 100 mil, hope you know. 0.54 gram in okay, mistake, good. 0.54 gram in 10 mil. But we are asked to find how many milligram will be milligram per mil. So what we are going to do is this. Putting this as a fraction, we have what? 0.54 gram over what? 10 mil. What it means is that we are going to move this to what? Milligram. Are we together? If you move it to milligram, it becomes what?
540 milligram.
5 what?
40 milligram.
Milligram. Over what?
10 minutes.
We're not done. We say in 1 mil, not in 10 mil. 540 milligram in 10. This one is 540 milligram in 10 mil. Hope you know. But we want to know the milligram in mil. So we divide. We will keep dividing until this 10 disappears. Are we there? So if we divide, we have what?
54.
54 watts
Milligram
per mil over 1 mil, which is what? 54 watts milligram per mil. Does it make sense? Does it make sense? So that's the answer to question number 1. We know that generally that 5.4% is 5.4 gram in 100 mil. We bring it down to what? 10 mil. We now start moving the playing with the units until we arrive at what? Milligram per mil. So the answer is what? 54 watts milligram per mil. This body is not even clear at all. Excuse me. Shall we? Good. Let's question B. So I can clean here, right? Yeah.
Yes. Yes.
No. Let everyone write. This one about let carry the votes. They should write first, so we can continue. Let me know. Oh. What do you have? By what time? Now. Okay. He's not here now, so after break, we come. Second time again. Now look at. All right. Let's finish this question first. Then we know the next line of action. B says, if a patient, let's listen carefully. If a patient used 5 drops of the otic solution, equivalent to 0.25 ml, how many milligrams of benzocaine would have been administered? So we are going to what? Benzocaine now. So concentration of benzocaine is what? Which is what? In what? So how many will be in 10 ml? How many will be in 10 mil? 1.4 gram times what? Over 100 mil, which is what? 0. What? 0.14 what? Gram, right? So 0.14 gram of benzocaine will be in this 10 mil, right? Good. Now, we are told that 5 drops was administered, Nante, at 5 drop, Nante onya. And that 5 drop that would drop in the person's ear is equivalent to what? 0.525 what? Mil. Are we together? So, how many milligram will be in that 0.25? Remember that 0.14 gram is in what? Let me remember, okay? Now, but 0.25 was administered, right? They want to know how many milligram will be must have been administered, would have been administered if 0.25 was administered. So if you have, what it means is this: if you have 0.1, this thing is not. Why are this marker green like this? Can you see the ball clearly? If you have 0.14 gram in what? In 10 mil, right? If you have 0.14 gram of benzocaine in 10 mil, how many gram will be in what? Will be 0.25 mil, right? So S is now equal to what? Times 0. What? Over what? What's the answer? 0. What? 35 what? Gram. Are we together? So 0.0035 gram of benzocaine will be in what? In what? 0.25 mil, right? But we are asked how many to define it in what? Milligram. This is in what? Gram. Okay? So we move this to what? Milligram. Simply by multiplying by what? 1,000. You get the answer. Multiply by 1,000. Times what? 1,000 is what? 3.5 what? Milligram. So 3.5 milligram. So when 5 drops is administered in the patient's ear, 3.5 milligram of benzocaine would have been what? Administered. Are we together? 3.5 milligram of what? Benzocaine would have been what? Administered. Is it clear? Any question there? Any question there? So it's clear. Yes, sir. Yeah. Okay, the C part says how many microliter? Are you sure this is microliter? How many microliter of acetic acid will be used to prepare 10 ml of the what? Drop. Let's go to the acetic acid now. We are now moving from weight in volume to what? Volume in volume. Because acetic acid is liquid, okay? Acetic acid is what? All these things here have been weight in what? Volume. Weight in what? Volume. But acetic acid is what? Volume in what? Volume. Does it make sense? So when you go to volume in volume, it will change. It's no longer, it is weight in volume. You start hearing that 1% is 1 gram in what? 100 ml. But in volume now, it will change. It's 1 ml in what? 100 ml. Okay? For the volume, it's 1 ml in what? 100 ml. For 1% volume in volume is 1 ml in what? 100 ml. So if 1% volume in volume is 1 ml, 1%, hey, 1% volume in volume is what? 1 ml in what? In what? 100 ml. So if that is the case, that means for acetic acid, 0.01% volume in volume is now equal to what? 0.01 ml in what? 100 ml. Are we together? Are we together? That's the meaning. That's the meaning of 0.01% acetic acid, volume in volume, because they are both liquids. So volume in volume, all 0.01 ml in 100. But the question says in what? 10 ml. So in 10 ml is what? In 10 ml. S is what? 0. What? Times 10 ml over what? What's the answer? 0.001 ml. Good. So we have 0.001 ml of acetic acid in the what? 10 ml. But they want us to find it as a microliter. What is microliter? How can we move 0.01 ml, 0.001 ml to micrometer? Sorry, microliter, sorry. How many liter make 1 milliliter? How many? 1,000 what? Mils make 1 liter, right? 1,000 mils make 1 liter, right? So if 1,000 mils is 1 liter, so 1 microliter. Micro is 3 per what? Minus what? Minus 6 liter, right? Right? So now saying 3 per minus 6 times what? 1,000. Are we together? Which is 3 per minus 6 times 3 per minus 3 per what? 3. Are we together? Which is what? 3 per what? Minus what? 3. Which is what? 0. What? 00 what? 1 what? Mil, right? Right? So this is how many microliter? 1 microliter. 1 what? When we are doing this thing, this reason why we are doing all this is that time. If you understand this, it's simple. Just go do rough work, and 0.01 ml is 1 microliter. 1,000 ml is 1 liter. Micro is 3 per 6 minus 6 liter. So anywhere you see liter, you put what? 1,000 ml. Look at it here. Here should be what? 1,000 ml. So here is $1 mil. Exponential. This is 3 power minus 3 mil. This was 0.01. The same thing with this. So that means this 0.001 mil is 1 microliter. So the answer is what? 1 microliter. Shall we?
Yes, sir.
So we should clean?
Yes, sir.
Good. Let's solve D. So after this, I'll stop here. MC lecture has been here since, please. Huh? Your brain is occupied. No, if he comes and you can you can negotiate with him. So I should clean, right?
Yes.
Good. B. What will be the equivalent ratio strength, volume in volume, of polycosanol 410? Now, I will introduce amount strength, ratio strength, and percentage strength. So with that, you can solve this question. Amount strength is just that normal one, you know. That one we've been doing, milligram per mil. Okay. If you want to check amount strength, even in your chemistry practical, that concentration you are doing, that your mole per dm cube is amount strength. You know, amount can be a mass or weight. Amount, it can be moles. Go back to your chemistry. Amount of a substance can be mole, can be in what? Weight or mass or moles. These are the amount of substance. That's why you can convert from reactive mass to number of moles using the molar mass. True or false? Number of moles is what? Molar mass. Reactive mass over what? Molar mass. That's why they are measure of amount, moles and what? Mass. Now, if it is in moles, you hear things like mole per dm or mole per mil, as maybe is amount concentration, because we should talk about the concentration of the amount. If it is mass, you hear something like mass concentration. So mass concentration is also amount concentration. So that means at that level now, you hear things like molar concentration, mass concentration. Strength and concentration are the same thing. So if you both the mass concentration, molar concentration are two of them together make up what we call amount concentration. Am I communicating? Good. Now, but when you can move from amount concentration to this one we've been doing here, this percentage concentration. That one I have been analyzing here since. This is what we call percentage what? Concentration. Now you can move from amount concentration to percentage concentration. We are going here. Hope you know that's what we have been doing here since. Converting this to amount concentration, it becomes 5.4 gram in 100 mil. Hope you know that's the amount concentration. We move from percentage concentration to what? Amount concentration. So what I want to talk about now is how to move from amount to ratio concentration and how to express ratio concentration. So listen, ratio concentration is expressed in this form: 1/R, or simply 1. This is how to leave your answer standard way: 1 in R. You now put the type of the product, the consistency of the product, whether it is weight in volume or volume in volume or volume in weight, as case may be. Here they want it to be in what? Volume in volume. Okay, so our answer will look like this: volume in what? Volume. 1 in R, volume in volume. So what is this R? What it means is that to move, let's go back to the question. What are we talking about here? You poly what? Cosanol. What is the percentage concentration? They statistics told us to convert the percentage concentration to what? Ratio concentration. So I'll use this one now. I will move from percentage concentration to amount concentration. From amount concentration, I will now move to what? Ratio concentration. So that's what I want to use this one to do now. So this will explain a lot of things, but everything must be in this form, okay? So let's go. The first thing to do is just look at it here is what? What is the 0. What? So we have 0.01% volume in what? I agree. We know that this means 0.01 mil in what? In 100 mil. Okay? 0.01 mil in 100 mil. But this is in 100 mil. We are talking about amount we need in this preparation. True of us. So let's try and again. 10 mil is X, right? X is now equal to what? 0.01 mil times 10 mil over what? 100 mil. What's the answer? 0.00 what? 1 mil in what? 10 mil. Are we together? Good. So in this product, we have 0.01 mil polycosanol 410 in 10 mil. Now, this is what it. Let's move this. Let's move this to what? We have moved it to amount concentration. Hope you know. So let's move this to percent to ratio concentration. Look up. Do you know what this thing means? Is that you keep dividing this. Remember, we did the equivalent ratio. Remember we did equivalent ratio. Do you agree with me that this is certain as saying 0.001 mil over what? Do you agree with me? Do you agree with me? Are you sure? So if this is 0.01 mil in 10 mil, this 1 over R is simply telling you to find equivalent fraction of this in which the numerator is 1. Before you can work with ratio strength, the numerator must be 1. If not, you are not ratio strength, you are not doing ratio strength. So we find the equivalent ratio, equivalent fraction, or equivalent ratio in which this numerator is what? 1. Remember how to develop a equivalent fraction. You divide the numerator and the denominator by the same what? Value. So what can we do to this numerator to make it 1? You divide by this, right? Or you times by what? 1,000. The same thing, okay? So let's times by 1,000. Either you divide it by 0.001. If you divide here by 0.001, you divide here by what? 0.00. Or you times it by 1,000, times it by 1,000, it is the same thing. All right, let's do it. What will it give you? 1 mil over what? Over what? Over 10,000. Are you aware that these two things are the same thing? The same thing. They're equivalent to what? Fraction. Have you seen why we did the equivalent fraction? Those things were not jokes. This is the reason why we did the equivalent fraction. So these two things are equivalent fraction. We have succeeded in moving it in this form. 1 over what? R. We put this unit by the side because this unit will form what you call V over V. Hope you know. This will change to volume in volume. But this is 1 in 1,000. This is 1 over 1,000. 1 over R. So if you put it in this form, it becomes what? 1 in what? Sorry, 1 in 10,000 what? V over what? V. This is the ratio strength. 1 in what? 10,000 volume in volume. This is ratio strength of this in these products. That's the equivalent ratio strength. Does it make sense?
Yes.
Does it make sense? Any question? Ask. Yes. Some textbooks. What you just see is some textbook. What you just see is another one is to what 10,000. Yes, but we in pharmacy. If you go to all these people in community health, all those community health, where they mix dilute their disinfectants before it's, because they also apply this dilution. They dilute from a particular concentration to another concentration before they can use it to disinfect where they are working. If you see what they will see there is simply what 1 in what 10,000. But we here we go deeper than this. This is how you present it as a pharmacy professional. Am I communicating? 1 in 10,000 volume in what volume? Ask.
You say that 0.001 is this one that is saying how they do it.
What's that? What's that?
You say that 0.001 million enemies and then this thing at the same thing. How they do it? If you divide this, it will give 0.0001.
You learn what?
If you
it's fraction. Please, I don't like people driving us back to what we have done. We passed this level. We did this in ratio fraction, ratio strengths. Did it, so we did it in equivalent to what? Fraction. We did this in equivalent fraction. I simply told you to find the equivalent fraction in which numerator is 1. It's a simple thing. Two of us, give me the equivalent fraction in which the numerator is what? 1. So anybody that doesn't understand what we did here, that person is having issues in equivalent what? Fraction. It's as simple as that. There's no, I'm not missing word about that. It's either the person wasn't here doing a lecture, or the person did not understand it and kept quiet without asking questions. Are we together? It's so simple. I told you what equivalent fraction is. This and this are the same thing. Divide this by this and divide this by this. Tell me the answer. Are they something? Yeah. They are something. So this is 0.01 mil in 10 mil. Look at it here. We put it this is a ratio, hope you know. This in this, hope you know, is a fraction. This in this is a fraction, hope you know. So we put it in this form. We then find this equivalent fraction in which the numerator is what? 1. So our target, listen carefully. I keep saying this again before you come to me and spend on that thing. Listen carefully. Is what? Okay, thank you. I'm moving on. Listen again. I'm saying it again for the last time. I said our target in ratio strength is to make the numerator to be what? 1. So anything you can do to make the numerator to be what? 1, or the first term of the ratio. Hope you know that this is only the first term of the ratio. Hope you know. To make the first term of the ratio to be 1, or the numerator as the case may be, if you achieve that, you get the same thing you did here to make it to be 1. You do the same thing here, and that's what we did and got what? This. So that's why it's 1 in what? This male over male will turn to what? And even here is gram. You see carefully. I'm going to a situation whereby you have solid dissolved in liquid. And even here is gram, and here is male. If we shift it, here becomes weight in what? Volume. Are you together? But in this case now it's male over male. So we shift it, it becomes volume. That's what they ask us here. Are we together? We in pharmacy, we don't joke with this, but if you see normal, you can simply see what 1 is to 10,000. That is the same thing. But this thing doesn't actually fully define this product. Are you aware? Because this thing doesn't fully define the product. You don't tell us what dosage form it is. Does it? We don't know the dosage form now. But when you see this, you know that it's what? Liquid what? Dosage form, in which the ingredient is also what? Liquid. Liquid dissolved in what? Liquid. Are you okay now? Please, I beg you, please go back to those. Listen carefully. You see those first. Remember, I told you that this before. You see those first 2-3 topics we did. Please remember them again. You keep seeing them here. You keep seeing them. They will keep appearing. I beg you. All right. In the absence of any question, I think we'll stop it. We'll try for today. See you tomorrow. God bless you.